Okay, so welcome everybody. What we're going to do today is I'm going to go through how you can use the Design of Experiments add-on to the Stat Helper to run some experiments and see some analysis. So let's go. So what you can see right here is the actual problem we're going to work on. This is your typical industrial type experiment. You have an engineer that's interested in the effects of cutting speed, tool geometry, and cutting angle on the life and hours of a tool machine. So at this point we can see we have three factors, A, B, and C. Our response is continuous. It's time. Since it's hours or lifetime of a tool, we want to maximize. So our goal is going to be to maximize here. Here's the actual experimental results. You can see based on what it says here that we have two levels of each factor. We have three replicates, and we ran a 2 to the 3 factorial design. You can see the grid here of runs labeled plus minus, basically minus being the low, plus being the high. And remember, when we do this, this is basically short for -1 and +1. Then we have our label for our runs here, and then we have the actual three replicates here. Okay. Now, if you think about the way this was run, you're basically looking at they ran this design and got these responses, then they ran it again and got these ones, and then again and got these. Hopefully they did some sort of random order, but that's based on the data that we find. So what are we going to do here? We're going to estimate effects. We're going to look to see what's significant. We're going to reduce our model, and we're going to look at assumptions, and then what levels do we want to set each of these things to so that we can maximize the response. Okay, so now let's go take a look at the actual tool. One thing before we do is notice for the ABC, the actual treatment combinations, they go minus, plus, minus, plus, and then 2 sets of minuses and pluses, and then 4 sets of minuses and pluses. This is actually going to be in what we call standard order, so we don't have to worry about the runs being randomized and trying to match up our numbers with the correct runs, which will be nice. Okay, so let's go over and take a look at the tool. Okay, so we're in our DOE two-level factorials dashboard tool. You can see here we have a few different options. We can create a design, we can import a design, we can analyze a design. So we're going to start with creating, and we're going to create the one that we saw in the previous problem. So you'll see with the Stat Helper, everything is pretty predicated on the idea of a start button and a reset button. We also here have a download the design button. We'll see what that's for a little bit later. So let's start by clicking the start button. Okay, we open up this new table, and we see some different things that we need to, some information we need to input. First is how many factors we have, and that is going to be 3. So we'll click the drop down, we'll find 3. Over here we decide which type of design. Now with only 3 factors, you're not going to see a lot of choices here. We're going to run the full factorial design here. You'll see when we get into later weeks that we'll have more choices for this. This second box here gives us pretty much where we put in how many replicates, how many block levels, center points, do we want to randomize the design, that kind of thing. So from our problem we had 3 factors. Okay, we did not have any blocks, so we will keep block level at 1. We also had 3 replicates, that's why I changed this to 3. 3 factors, 3 replicates. No center points, and I don't want to randomize the design. The only time you really want to randomize the design is if you're creating a design to run. If you're creating a design to analyze, hopefully things are already set up before you even get that started. Then here we can put in information about our factors if you want to change the names, the low and the high level. I'm going to keep everything at ABC and -1 and +1. Okay, so now we're all set. We're going to click Run. Okay, and you can see here we basically come out to some output in our dashboard here. First is the design table, which gives us the actual design we created. Notice plus minus, 2 minuses, 2 pluses, and 4 minuses, 4 pluses. Then it repeats. We also have what we call an alias structure table. This is not going to be an issue right now. Later on, this will be important for us. Also, we have a design summary. So this just tells us, okay, you got 3 factors, we have 8 runs, and you have a full factorial. Okay, so at this point, what we're going to want to do is download the design so we can load in the responses. So we're going to click the download the design button. And what that's going to do is it's going to download and create an Excel file with your design in it. So let's click on this. Okay, and you can see here that here's our A, B, C columns. They match what we saw. What we're going to do is we're going to add a column for Y after I enable editing here. Okay, where Y is our response. Then I'm going to go back to our experimental table, and I'm just going to bring all of these responses right in. Okay, I'm going to bring them into Excel. Notice we need them stacked. They're not yet, so what I'm going to do is I'm going to cut the second replicate, paste it under, and then cut the third replicate and paste it under. Okay, I'm also going to format so everything's the same font. That's just a pet peeve of mine. And at that point, we should be all set. One other thing you should understand is you just have to keep replicates consistent. I went replicate 1 with step 2 under it and 3 under that. If you want to do 3, 2, 1, 2, 1, 3, it doesn't really matter as long as the runs stay with the right runs within a replicate. Okay, so now that we have our design, we have our responses set in. Now let's do some analysis in the table. So what I'm going to do is I'm going to save this. This was output number 6, so we'll hit save. And then I'm going to go back to the DOE Dashboard. Now I'm going to go to the tab that says Import a Design. I'm going to click the Import a Design button. Now it's asking me, okay, where's your Excel file? So I'm going to click Browse. I'm going to go find my Excel file. Remember, it was number 6. Okay. Now this opens up some new information. Okay. If you have multiple sheets, you can select the right sheet here. Okay. First, we need to select the response, which was Y. Then we need to select the inputs, which were A, B, C. And finally, we didn't have any blocks, so we're not going to need to worry about a block variable. Okay. Once you get all of this information in, just click Run. And what happens now is you've actually loaded the design into the dashboard tool. Notice, let's assume that maybe I didn't say Y as the response. Maybe I said lifetime. Okay. And I had the actual titles in here for each of these. It would just, this label table just tells you, okay, this is what you had originally, this is what you'll see now. Okay? Same here with this code table. The low level was originally -1 all the way across, and now the new level is -1, etc. So that just gives you an idea of how things are set up in terms of coding. We also have some summary tables, just like we saw with the created design. The first summary table tells us 3 factors, 24 runs. The second one shows us the actual design with all the responses. And the third one gives us what we call alias chains. That's not as important right now for these full factorials, but when we get to more complicated situations, the alias table will be really important. Okay, so now that we have our design imported in, let's do an analysis. So we're going to click Analyze the Design. And you can see I have a few buttons here, Analyze, Reset, and then Download Results. We'll see what these are. First, let's click Analyze. So we open up this box. It basically says, okay, first tell us what you want to use for alpha. And in most cases, you're going to use 0.05, so we're going to leave it at that. Now tell us what your goal is. Okay, well, my goal, I can choose max or min. We saw we were dealing with lifetime in hours, and we want the tool to last as long as possible, so we're going to choose maximize. Now, this last one is a bit of a unique thing you find in some software. The type of analysis, you can do a manual analysis where you control everything, or you can automate it where you let the tool make all the decisions. Let's look at automated first. We're going to click automated. Okay, so now we have our alpha, we have our goal, which was maximize, and we also are doing our automated results. Okay, so let's just stop right here for 1 second before we start this. One thing I want to make perfectly clear about this automated design is it's really built more for industry than it is academics, and you will need to know how to do this analysis manually. Okay, so the automated function is great. It basically tells you exactly what to do. It does your model reduction. It tells you what levels to set everything to. It's really, really great in terms of all of that. But just remember, when you get to an exam or if you have to deal with anything like that, you're going to have to be able to do these things manually. So just keep that in mind. Okay? All right, so let's go back. Okay, so we're back here. Let's do the automated design first. Click Run. And now you should notice we have these 4 tab boxes here. Okay, we actually have a tab box for outcomes, a tab box for tables, a tab box for assumption plots, and a tab box for effect plots. So we'll come back to this outcome tab box in a minute. Let's start over here. First, the effect tabs. So this is basically your reduced model, what I like to call the t-table, because it's going to give you your effect, but it's also going to give you your t-value, p-values, etc. Okay. So based on the analysis that was done by the tool, main effects A, B, and C need to be in the model, and the AC interaction. Now we can see this because B, C, and AC have p-values really, really small, much less than 0.05. A does not have a p-value that's small, but you should remember that because AC is significant and it's a two-way, you need to have the 2 main effects that make it up in the model. Okay. So now let's look at the ANOVA table. Basically, you should see the same output here. Okay, just based on F values instead of P values. Then we also have what we call an assumption table. And the assumption table, what it is it shows the 3 different assumptions that we make on errors: independence, equivariance, and normality. Okay. Then it gives you the P values for those tests that you run. And then it'll tell you whether the assumption was met or not. So basically, because all these p-values are not significant, we can assume that all our assumptions are good. Okay, so that was the table tab box. Let's go over here to the assumption plot box. You've got residuals versus order, residuals versus fits, residuals versus each variable that's in the model, and then, of course, the normal probability plot of the residuals. So basically what you would do with these is you would take these and you would make the decisions on the assumptions that you saw here, and you would make them based on the plots. And of course, remember, we're looking for basically no patterns. Okay? And I would say with these, we're probably pretty much there. Okay? And whether or not this hugs the line or not. Okay, so that's the assumption plot tab box. Let's look over at the effect plot tab box. Okay, so we've got effect plot A, B, C, and AC. So what we're going to use those for is we're going to use those to decide which levels to set our factors to. Okay, so remember, if you're dealing with a 2-factor interaction, you need to use that plot to decide which levels to set each variable to. So since AC was significant, we're using AC as a 2-way interaction plot here. So let's take a look at this. Here's the point that is a maximum. Notice for A, since A is on the horizontal here, we would choose -1 to get to this point. For C, since the line is blue, we would use +1 to get to that point. Now, since we have no interactions with factor B in them, we'll go to the main effect plot for this. And you can see from this, we would choose +1. So based on these effect plots, to maximize our lifetime, we would choose -1 for A, +1 for B, and +1 for C. Okay, now let's go back up here and go to the Outcomes tab. Okay, first it gives you your goal, right? Remember, our goal was to maximize. So what it basically tells you is, based on our results, the maximum response is going to be 54.17, and the levels to set the factors A, B, C to are -1, 1, and 1. Okay. We also have what we call a bonus outcome. If you ever come across a situation where one or more main effects or one or more of the factor main effects are not in the model, then what that allows us to do is to decide which level to set those to. And a lot of time we'll do that based on something else. Like, let's say you had a factor that was running time and that was not significant. What you would probably do is choose the lower level, which would be the shorter running time, to save money in terms of operations. Okay, so that's what we call, a lot of people like to call that the hidden factory. I call it the side bonus. Okay. We also have a tab for model outcomes, so it basically tells you, look, we kept B, C, and AC in because they were all significant, but we also had to keep A because it was part of a two-way interaction, or because of what we call hierarchy. Okay. And finally, for assumptions, since all the p-values are greater than alpha, we're going to conclude that the model is adequate. Okay. So basically what we did there with these 4 tab boxes is we were able to see all of the outcomes that we needed to analyze the experiment and draw conclusions within this dashboard. Okay. Now, one last thing that you can do with this is you can download these results into a Word file. Okay. So what we would do is click on this button here that says download the results. We see that it's creating everything down in the corner here with this thing. And notice it actually downloaded a Word file. Let's open it. Okay, so what the tool has now done is it has basically taken everything that we just saw in those 4 different tab boxes and outputted them and put them into a Word file. So now it makes life easy because you can just go in and just write your conclusions in the right spots based on the graphs or the output. Okay, so that pretty much in a nutshell is how you use the tool in terms of automated response. If you wanted to do this with doing it manually, what you would do is, let's reset the inputs. Again, we would go analyze. Now, instead of choosing automated, we're going to do the drop down. We're going to change it to manual. And then here is where you're going to decide what goes in the model or not. Okay, so to start out, you would basically select everything, click Run. Now, if you do automated, if you don't do automated, you're not going to see any of these outcomes, okay, because they're only given out when it's automated. You will see the effect tables, ANOVA tables, assumption table, etc. You will also see all of the residual plots and, of course, all of the effect plots. One thing you will notice here is there is no effect plot for ABC. The reason, one, is because it will almost never be significant, so we don't have to worry about it. And 2, it's a lot more difficult to create a 3-way effect plot. Okay, so you're not going to find it in here. Okay, so let's assume you go to the effect table and you say B, C, and AC are significant, and then I'm going to keep A for hierarchy. Reset the inputs, click the Analyze button again, go to Manual, and now all you're going to keep is A, B, C, AC. Okay, then click Run, and now you're basically back to what we saw with the automated response or the automated method. The only difference is, again, you still don't get these outcome tabs. But you know what? Other than that, everything else is the same. You can still download the results and everything from here. Okay, great. So that was just me going through how you do a problem with a full factorial in the DOE tool add-on that I'm going to put into the stat helper. Look down in the comments below. I'll put the address that you can go and you can play around with this tool. And please let me know what you think in the comments. Like, subscribe, all that fun stuff. So thanks for watching.